Hello, this is Mr. Taylor with Young Engineers of Today's 5th and 6th grade course for fall of 2015. This is a recap of Monday, September 28th, 2015's webinar. Today, we started 3D design. 3D printing, you can create almost anything you can imagine, from small, detailed items like you see here to items that are changing science, engineering, and the medical industry. Prostheses are being printed for under $30 that are helping people who are missing part of their limbs or whole limbs, etc., from birth to accidents to military or etc. And it's doing at a rate that's rapid prototyping style. And it's a wonderful tool. This past summer, 3D printed car was created. Now, when you hear this, don't think everything is being created out of plastic. The majority objects are. Now, with that being said, it's an amazing tool that is changing the game on how we do things. It's providing the opportunity to bring things to life that would take a lot more money, effort, and time and experience. Now, what we're going to review here is what is 3D printing, how does it work, examples of 3D printing, brief history of 3D printing, and about open source in general, and then Tinkercad. Now, what is 3D printing? It's an additive manufacturing process of making a 3D solid object of almost any shape from a digital model. I try to use the example of it's like an artist making something out of clay. They're building it out, up into, for example, a vase or piece of pottery. You're adding on to each stage of it. Now, 3D printing can be summed up into three major areas. The design of an object or a product is being done in a software. Now, the software, such as SketchUp, Tinkercad, that we'll be learning this evening, AutoCAD, SolidWorks, AutoFusion, 123D, Make, 123D Design, Mesh Mixer, etc. There's so many of them out there right now, ranging from free products to paid products, from introductory to professional usage. Now, once someone has designed an item, it is sent to a machine. Now, when it's sent to a 3D printer, these 3D printers are usually reading STL files. Now, on those machines, they convert a lot of this into G-code, which is the machine-based language that gives coordinates and instructions on where to print where. Because the majority of these 3D printers are basing everything off of X, Y, and Z axes. And then it prints them out, the machine itself, layer by layer. It's like as if you had taken a hot glue gun and I told you I want you to make a box, and you would just keep gluing down layer after layer. Now, the opposite of the additive process is the subtractive process. The example I like to use for this is when an artist chisels away a piece of maybe marble to make a statue. You're taking away, okay? Now, the major difference in all of these 3D printers that are currently on the market is just the way they lay out everything when they're assembling it, okay? Here are some objects that have been made with 3D printers. Now, depending on the size of your print area, your print bed, the detail that you're trying to get, the speed at which you're printing can really change everything. Now, a little brief history. Chuck Hall in the 70s, considered to be like one of the father of 3D printing, created the first 3D printing machine and developed the STL file format that is being used. The stereolithography style of 3D printers is XYZ. A lot of different other types of 3D printers are all based off of this style. And then another area is like polar printers, which the Z in the y-axis are on a spinning polar type plate, if you will. Okay. Now, relating it back to Moore's Law, saying that Moore predicted that technology's memory and speed, computing speed, would double every 18 months, and this has held true since the 60s when it was developed, this theory, and things are getting smaller, faster, and cheaper. 3D printers, I've been working with 3D printers about 4 or 5 years now. I've ranged from using software to design items to repairing 3D printers to building 3D printers, and working with a variety of, from MakerBot to PrinterBot to Polar 3D to Hi-Rel to UPS and cubes. So there's a wide variety I've had the opportunity to work with. And everything has its pros and its cons. A lot of them are wonderful, and the whole 3D printing community is wonderful. But about 4 to 5 years ago, I was getting printers and working with, they were like around $2-3 grand. Now you can get printers that are around $600, give or take, and they're printing really well. Open source. Open source is the movement of people doing and creating and making and improving. It could be a software, a machine, a product, etc., where there's no one really getting paid. It is intrinsic motivation that is advancing society and improving society. And people are doing it for their own enjoyment and for their own learning and growth. And RipRap machines were one of these. They're their first self-replicating manufacturing machine. Basically, you could buy one, build it, and then print out all the parts that were non-mechanical or electrical. So all their blueprints for them were completely open sourced. MakerBot Replicator, quality product, founders from the maker community, for completed 3D printers. They helped create Thingiverse. Thingiverse is really cool. Check it out. You can do a Google search on it. It's a great 3D printing file community. Now, we're going to get into Tinkercad. When you go to Tinkercad, tinkercad.com, you just sign up. Don't make sure you're not clicking on sign in, but you're signing up. And when you sign up, you make an account, and then it will automatically take you to a lesson. If you click on Tinkercad, the logo here, and you close that, you will go to your dashboard. Now, the dashboard's really cool. Allows you to create new projects, look at practice lessons, and all the projects that you have been working on. Now, there are 4 basic lessons that I recommend you doing. Basic moving camera controls, object interaction, inspector, and object manipulation. The moving objects can be moved by either clicking or dragging or using the keyboard arrow keys. Note how changes in distance are displayed helpfully. Objects can be moved by either clicking, dragging, or using the arrow keys. Objects can also snap to grid to maintain accuracy in moving things without being too sensitive to the mouse input. Then you have your moving the camera. 2 primary ways to control the camera using the navigation located in the top left corner of the screen, your arrows, your home button, your zoom and controls, or you can use your mouse by holding down the right mouse button and move the mouse in desired direction. And if you have a wheel, you can zoom in and out. The making holes, the orange area shows where the hexagon prism should be placed. Correctly place the hexagon prism there. And before finishing the wrench, we take a quick look at the inspector window. When an object is selected, the inspector allows you to either color it or make it a hole. The key to building more complex shapes is learning how to combine solid and hole shapes together. So in this case, we changed that hexagon to prism into a hole, highlighted the wrench and the prism, and then grouped them. Now, each object has a bunch of dots on them, and these dots allow you to raise up using the red, black arrow on top. The upper white dots make objects taller or shorter. You have lower dots extend or compress, and then curved arrows rotate. Okay. Basically, quickly, when you have an account, you can change all your account information here. You can go to your profile, etc. Here are all your designs and your projects, your lessons that you completed. If you want to create a new project, you can create new here, or you can open one up. If you open one up that you already created, you can click Tinker this. Now in here, if you go to Design and you go to Properties, you can change the name of it. David name tag. And I can make that private or public. If it's public, it shares it with the community of Tinkercad so people can use yours. You can copy it and paste it, and they can give you feedback, and you can do the same with everyone else's. One of the great tools for using here, when you look through this, here, this is my work plan, so I can change where I want to work. I can just click on something, and it shows I'm working on there now. It's very good for building level surfaces on the side of things, for example. The ruler is recommended to use on the outside, and what will happen is now I can actually type in values, where without the ruler I can't do that. I can only just move it. Okay, you have your geometric shapes that are pre-made. As you scroll down, you'll also have your hole shapes. You have your letters, you have your numbers, you have some special shapes that you can use, symbols, etc. You can see all of these are open. You'll also have all these specialty shape generators. Basically, the shape generator does this. All of them will come out here, and you can change the sides, the radius, the size of it, the height. And that's what these tools are for. And one of the beauties of if it's highlighted, I can just hit delete and it's gone. Okay? That's some of the basic lowdown of some of these tools. See, this is where you have the hole, where I can manipulate this shape here. And all of these have special features. So it's very artistic. I can also align things. Aligning just means that if I was using multiple objects, this allows you to center it. Okay. So with that being stated, that's just some basics for doing that. I'm going to go to Design and close this. And then next thing I want to show you is the gallery. This is where you have the public community if you make your things public. And you can search just about anything. I like Batman, so I'm going to search Batman. First, you'll see all the users, and then you'll see all the different Batman objects. Now, what you can end up doing is taking the Batman object, and you can make it your own, take a copy of it, and you can tinker it, or you can download and print it. Now, you can also go to Learn. Learn will have more lessons. I recommend you trying to do over time as many lessons as possible. The more lessons you do, the better you are at this. There's about 30 of them, give or take, overall. That is a recap of Tinkercad. Hopefully you enjoyed it, and thank you for being part of YEOT.